Hey folks, so this is going to be the second video in section 5.3. And to be quite honest, this is probably one of the most important videos that I will give you throughout the entire semester. So this is one that you might want to watch multiple times. All right, so what we have here, I want to look at this concept of special triangles. And so you see that I've started out with an equilateral triangle. And I've said that every single side on the equilateral triangle is worth 2 units. We know that equilateral means that all 3 sides are the same length, all 3 angles are the same measure, which is why we have marked all 3 of those angles as 60 degrees. So then if I take this triangle and I split it into 2 equal triangles or congruent triangles where they're the same size, the same shape, and there's a couple of things that I notice. One thing that I notice is that my 2 little triangles are both going to be right triangles. Notice that the hypotenuse on both of those right triangles is still 2 because that side was not messed with at all. Since we split it in half, we would say that each of the short legs is going to be 1 unit. Notice that this angle down here at the bottom, these guys are both going to be 60 degrees because those were untouched from the original triangle. However, this one up here was split in half, so these little guys up here are both 30 degrees. Now, one of the things to note about this is frequently this is called the 30, 60, 90 triangle. Because we can mark it by the 3 angles. Now, there is one side that I didn't look at. How long is that longer leg? And so we'll do a little bit of Pythagorean Theorem to figure that out. So if I have my short leg, 1 squared, plus my long leg, y squared, is equal to my hypotenuse, 2 squared. Do a little bit of math here. Y squared will equal 3, so therefore y is going to be positive or negative square root of 3. Of course, it's going to be the positive root 3 because this is a distance. So this long leg then, both of these are square root of 3. Okay, so then what if I take this and ask for you to find the 6 trig values for a 30-degree angle. And so I'm focusing on only the 30-degree angle. You know, in the last video, we looked at the 6 trig values of an angle A or an angle B. In the previous section, in section 5.2, we were looking at the trig values of theta, which it was on the x and y axis where theta was at the origin. So now we're looking at the sine of just 30 degrees. So we're focused on that 30 degrees, but we'll still use SOHCAHTOA here. So we'll have sine of 30 degrees is going to be the opposite divided by the hypotenuse. So it'll be 1/2. The cosine of 30 degrees is going to be the adjacent divided by the hypotenuse, so that's going to be root 3 over 2. Tangent of 30 will be the opposite divided by the adjacent, so that's going to be 1 divided by root 3. But remember, you never leave roots in the bottom. You'll rationalize the denominator, so it'll be root 3 over 3. To get my other 3 then, we'll just get the reciprocals. So my cosecant at 30 degrees is going to be 2. My secant at 30 degrees is going to be 2 divided by root 3, but then we'll rationalize the denominator, getting 2 root 3 over 3. And then last but not least, my cotangent of 30 degrees is going to equal root 3. Now, what if I take this same triangle that I've been working with, but now we say that the hypotenuse doesn't equal 2, but the hypotenuse is equal to 1. And what I can think of this as is that if I can go back to maybe this one up here, actually it's probably easier to look at this one. If the hypotenuse now is 1, well, the first thing that you want to ask yourself is what is always the relationship between the short leg and the hypotenuse? And you'll notice that the short leg is always going to be half the length of the hypotenuse. So then that's pretty easy. If my hypotenuse is 1, because the directions say it is, then that means the short leg is going to be 1/2. Now I could do the Pythagorean theorem to find the length of the long leg, but again, let me take you up to this picture here. And just think about the fact of the relationship with these two. And the relationship here is that if I take the short leg and multiply it by the long leg, I'm going to have 1 times root 3. And that gives me the length of the long leg. So for instance, let's just throw something out there. Let's say that this is 10. Then we know the short leg is going to be 5. Well, if I'm going to get my long leg, all I have to do is take my short leg times the long leg. So it's going to be 5 times the square root of 3. And so I have 5 times the square root of 3 then for the length of that long leg. So with that said then, if I just take a half, and I should say I'm going to be multiplying by that square root of 3 to get the long leg. So this is going to be a half times root 3 is going to be root 3 over 2. Now, I mentioned that this is one of the most important lessons that I'm going to talk about in this particular section, well, really all semester long. So what I want you to do is I want you to fast forward, skip over the next couple of sections here, and let's go back to the unit circle. Now, we talked about the unit circle in a previous section, so this is not new. So some of this is going to be review. So very quickly, let's simply review the degree positions on the unit circle, the degree positions on the unit circle. And notice that because it's a unit circle, we are assuming that the radius is equal to 1. That's the definition of a unit circle. My radius is equal to 1 unit. So we're going to go through it pretty quickly. We have 0 degrees. Remember that when we were in class, we counted by 45s to get all the way around the circle. So we have 0 degrees, 45 degrees, 90 degrees, 135 degrees, 180 degrees. Down into the third quadrant, we have 225 degrees, 270 degrees, 315 degrees, back to 360 degrees. So that's all counting by 45s. And then the second thing that we did in class was we counted around by 30s, and every slice was worth 30 degrees. So we have, again, starting at 0 degrees, and then 30 degrees, 60 degrees, check our work at 90 degrees, 120 degrees, 150, check our work at 180, 210, 240, check your work at 270, that's another 30 is going to be 300, then 330, and we can check our work at 360. So that's just a real quick recap of what we did with degrees. Now let's do the same thing with radians. Again, this is a review. So this is not something that I'm explaining my way through it. You would have to go to a previous video for that. So let's start. I'll do this in a different color. Let's start with 0 radians. So I'm just going to put 0 here. And remember that instead of counting by 45 degrees for radians, we counted by pi over 4s. All right, so this was 1/4 of a pi. This was 2/4 of a pi, but we wrote that as 1/2 of a pi. So then we had, that was 2/4. This one's going to be equal 3/4 of a pi. And then we have 4/4 of a pi, but we'll reduce our fraction to just say pi equals. And then down into the third quadrant, if we're continuing to count, 5/4 of a pi. Down at the bottom, we'll have 6/4 of a pi, but we always reduce our fraction. So instead of 6/4, we'll write 3/2. But that was at 6/4. Into the fourth quadrant, we have 7/4. And then last but not least, we have 8/4, and 8/4 is the same thing as 2 pi. So that takes care of all of our 45 positions or pi over 4 positions. And then the last thing that we did in radians is that we counted by pi over 6s. Each slice is worth 1/6 of a pi. And we reduced our fractions along the way. So this is 1/6 of a pi, or pi over 6. This one here is 2, 6, but we wrote that as pi over 3. At the top, we check our work. That's 3, 6, and 3, 6 reduces to 1/2. Then we had 4, 6 of a pi, which is going to reduce to 2 pi over 3, 2/3. After 4, 6 is 5, 6. After 5, 6 is 6, 6, which makes sense. We're checking our work. And then we have 7, 6. 8, 6, but we'll write 4/3, reduce our fractions, but that was at 8, 6. 9, 6 really does reduce to 3/2. 10, 6 will be 5 pi over 3, 5/3. After 10, 6 is 11, 6. And then after 11, 6 is 12, 6. And once again, 12, 6 will reduce to 2 pi. So again, that's just a review of getting the degree and the radian positions all the way around the circle. Now, let's use this concept, assuming that our radius is 1, and let's get some coordinates around the circle. Let's get the coordinates along the 4 axes. So if my radius is 1, this is going to be the coordinate at 1, 0. Up at the top of the circle, if my radius is 1, this is going to be the coordinate 0, 1. On the left side of the circle, this is going to be at -1, 0. And down at the bottom, you'll have the coordinate 0, -1. Okay? Now, what I want to do next, and I've actually given myself some triangles here. So let me just grab one of these triangles. I'm going to move it up to my unit circle. Notice that I'm using here my 30-degree angle. So that means that this guy is a 30-degree angle. And if this is 30 degrees, then that also means that this angle up at the top of the triangle is going to be a 60-degree angle. Now, I'm hoping that you can look at this. This is a 30, 60, 90 triangle. And I'm hoping that you can see that there is a short leg and there is a long leg. If I follow the long leg, that's going to be my x value because it's going to the right. And so my x value here is going to be √3/2. And then my y value is going to go up. And that's my short leg. And my short leg is going to be 1/2. And that goes back to what we just went through with the 30, 60, 90 triangle right here. When my hypotenuse is equal to 1, the short leg is going to be equal to 1/2, and the long leg is going to equal to √3/2. Now I have several more of these on my unit circle. So let me grab another triangle. And let me place it over here. Once again, this is at the 150-degree position, but this is going to be a 30-degree angle right here, making this up here a 60-degree angle. And once again, I hope that you can see that there is a long leg on my x-axis and a short leg for my vertical value. So my coordinate on this one is going to be -√3/2. You say, well, why is it negative? Because it's going to the left. And since it's long, it's going to be the square root of 3/2. And my y value is going up, so that's going to be a positive 1/2. Now, I'm not going to continue to draw these triangles, but you'll notice that I have another triangle that goes down to this 210. Sorry, that's a really ugly triangle there, and I'll erase that. But take a look. You can see that this is my 30-degree angle. Over here is my 60-degree angle, so I have a 30, 60, 90 triangle again. The short leg is vertical. The long leg is horizontal. All right, so this is a little too ugly for me to keep here, so I'm going to erase it. But nonetheless, to get here, we're going to go to the left, √3/2, so that's a long leg. And we're going to go down 1/2, so that's going to be a -1/2. And then there's one more over at the 330-degree position, right here. In order to get to that 330-degree position, we need to go to the right, and it's a long leg at √3/2. But then we're going to go down 1/2, so that's going to be a -1/2. Okay. Now, there's another set of 30, 60, 90 triangles, so I'm going to get rid of these right here simply so that they're not in our way. Okay, so let me go down and grab another triangle. Pull it up. Notice that this one takes up 2 slices of my circle. So I'm going this far, 60 degrees. So there's my 60-degree angle. This is my 30-degree angle, and here's my right angle. Hopefully, again, you can easily see that there is a short leg and a long leg. So my x value is short. So that means that we will have 1/2 for our x value, but our y value, our vertical value, is long. So that's going to be √3/2. I also have one at 120 degrees. And if it helps, I will grab another triangle here. And once again, what you can see is that this takes up 60 degrees. This is 30 degrees. I have a short leg and I have a long leg. So my short leg is going to go to the left 1/2, so it's negative, but my long leg goes up √3/2, so that's going to be positive. Down on the bottom of the circle, 240 degrees, I have another set like this. My x value is short, so it's going to go left 1/2, so it's going to be negative 1/2. And my long value is going to go down √3/2. And then at 300, same concept. We're going to go to the right 1/2, so that's positive, right a short value. And we're going to go down a long value, so that's going to be negative √3/2. So that now I have a coordinate for every single slice, as well as the axes. Okay, stay tuned, and I'm going to add even more to this particular picture in the next video.